Hey everybody, it's Jason Blaha here, and today I want to chat with you guys a little bit about this bodybuilder theory of time under tension and why it's not really based on reality as it pertains to hypertrophy. But what we need to understand is that it has an element of truth to it. Now, I'm only using the word theory loosely as a layman's term. It wouldn't be a scientific theory, it would be an unfounded hypothesis. But the average person knows what the word theory is, and I don't think we need to get that too mixed up. People will complain when I say something like that, though. It's their theory. And it's based upon a couple of factors. One of them is obviously bodybuilders like strength coaches and researchers and everyone else have noticed if you do more total training volume, you generally do get a little more muscle growth, right? We know that work done, total training volume, as long as you are able to recover from it, larger amounts of training volume generally cause a little more muscle growth than lower amounts do. In other words, if you take 300 pounds on the barbell for a squat and you do 3 sets of 10 with it, you might get good growth if it puts you outside of your normal training. In other words, if there's some progression there and you can't just easily do 3 sets of 10 with 300 pounds over and over and over, every single week, if it's a novel training response, you're probably going to get some muscle growth out of it, right? But if you do 5 sets of 10, so you did 50 total reps instead of 30 with 300 pounds, you would probably get slightly more muscle growth out of it. It might not be enough for you to visually see or to measure, but you'll generally get more muscle growth because more total work, more training volume, which is more time under tension, right? Because adding 20 reps has tension time. There's actually time involved. It takes seconds, quite a few seconds to do 20 extra reps. That's more time under tension, but it's not because it's the time under tension that causes the muscle growth. And that's where you can see a misassociation. It's the training volume, the work done. I mean, doing 50 reps with 300 pounds on a big movement, especially something like a squat that has the potential for a lot of range of motion, that's a lot of work, right? That's a lot of work in anyone's book. But it's the workload. It's not the tension time that matters. And one of the reasons this whole idea came about was that bodybuilders figured out decades ago, and I'm talking before I was born. Yeah, and I'm 42, and so it was before I was born. They figured out that if you move a weight really slowly, sometimes you get a lot more sore. And they associate sometimes more soreness with more muscle growth, because if you got sore, you must have had a good workout, right? But that's not necessarily true either, right? That maximum growth stimulation doesn't always cause soreness, and muscle soreness doesn't always mean that you got a good workout that made you grow. There can be overlap. It can be an indicator. It can be one indicator that you got good stimulation, just like a pump can sometimes be an indicator that you got a good workout stimulation with enough volume, right? It's not guaranteed. The pump itself doesn't cause growth. The soreness itself doesn't cause growth. There's sometimes side effects that we get from certain types of training stimulus that oftentimes do make you grow. But they're not a guarantee, and their absence doesn't mean that you didn't grow either, because it is workload, training volume. And training volume is honestly on any exercise is usually how much weight did you lift for how many reps and how far did you move those reps, right? The amount of work that you did with your muscles is usually the number one factor in how much growth you stimulated in a workout. And that's what experts are finding. In other words, even the researchers are kind of figuring out, more work, in other words, doing more work instead of less work, usually causes better muscle growth, right? That's what causes growth. It's workload. Well, the problem is that you don't get better workload or muscle fiber stimulation by moving a weight slowly. That's the problem. In fact, when we think in terms of work, time under tension is actually a negative. If time under tension is correlated with more work because you did more total reps, hey, that's great. Then in that case, the time under tension does have more muscle growth associated with it. But the time under tension itself, the amount of seconds that it took you to do that work, is actually a bad thing. In other words, the lower that number is, the more stimulation you got. And that's not just a theory based on physics. I mean, the physics confirm it, right? We could pull up mathematical formulas and prove that. because force generation, right? In other words, moving your 300-pound squat from parallel to lockout, if you did it in 2 seconds, that would be pretty good. But if you did it in 1.5 seconds, you accelerated the weight faster. And if you did it in 1 second, you would accelerate the weight even faster, which is even more force. When we study it and we hook electrodes up to measure muscle activation, which of those do you think causes more stimulation and more muscle fiber recruitment? The fastest ones, and the slowest ones cause the lowest every single time. So with any given weight, the faster that you move it, the more muscle fibers you stimulate. So actual tension time is a bad thing. It's a bad thing. And that's based upon physics, and that's based upon research in muscle fiber recruitment. Now, then we get over to the slow negative thing. We run into the other problem, because that's the concentric. That's the lifting the weight. What about the lowering it? Aren't eccentric reps associated with muscle growth? Sure they are. Sure they are. They're also associated with making you more sore. Now, the literature and the research on concentric reps versus eccentric is actually very cloudy, because here's what you find. Controlled eccentrics do add more workload, right? We know that. But if it's a weight that you can lift, the lowering it doesn't have very much growth stimulation. It is inferior because it's easier. We are stronger on eccentric reps than we are on concentric reps. And so people will look at that and say, aha, so therefore there's more potential for work. Well, it's an inferior stimulation because we can lift more weight. We can lower more weight than we can lift. Therefore, lowering a weight requires less muscle fiber stimulation than raising it. So do the eccentric reps add part of the growth on a normal work set? Of course they do. But they don't do as much as the concentric does. And here's what we find. Usually anything more than about a 1 second eccentric doesn't have any additional growth stimulation. This has been studied decades ago. Like 20 years ago, they looked at this over time and then measured muscle growth. And they found that people who did no eccentric rep on the exact same reps and sets, like if you put X amount of weight on the bar and have people just do the concentrics, versus those who did an eccentric with a 1 second lowering, the people who lowered the weight and did an eccentric rep instead of just turning loose of it did gain a little bit more muscle, right? Okay, so there's proof that eccentrics do have some growth stimulation, right? We know that. But when it's been compared, when you do a 4 second versus a 1 second, there's no additional growth. But what you do get is more muscle soreness. And muscle soreness doesn't always mean muscle growth. So it takes more time. You get more sore, but you don't get any additional muscle growth. Now, conversely, we also find that explosive concentric reps can stimulate maximum muscle growth too. And there's coaches who have their lifters during bulking phases only train that way in certain sports that have an explosive component. What did they find? They can bulk their lifters up just fine, but they have to do more work. In other words, doing only concentric reps with no concern for eccentrics and turning loose and just not controlling them can stimulate the same amount of muscle growth, but you're required to do more total reps to make it happen. So it's not necessarily time efficient. So actually doing a somewhat controlled 1 second, eccentric rep on your exercises will get you out of the gym faster. You need less total reps and less total sets to stimulate maximum muscle growth. But it's not a requirement. And what we find when we start talking about the time under tension aspect of it, when you look at it from that perspective, if lifting a weight twice as fast produces better stimulation, then what does that mean? That means that time under tension on the lifting portion is a bad thing. In other words, if we wanted to do 10 reps, if you got them in half a second versus 1 second, we shaved 5 seconds of time under tension off and got better growth. So the tension time is a bad thing on the concentric rep. And then on the eccentric rep, it only counts to a certain threshold. If you have control of the weight, that seems to stimulate maximum eccentric growth. If you lower it even slower, it has no positive measurable benefit. It doesn't recruit any more muscle fibers and it doesn't cause any more muscle growth. So it's neutral on the lowering. So when we talk about time under tension as if lifting weight slower is a good thing, it's not. It causes less muscle growth, and it sure as hell trains you to be a lot less explosive. There's actually no merit to focusing on time under tension unless we see it as a bad thing and say, oh, we want to lift as fast as possible with good form, right? We don't mean bouncing a weight off your chest and exploding and lifting your ass off the bench to do it faster. We mean with good form, right? All right, guys, but that's really all I have to say on that today. I hope it's been informative, and I will talk to you guys next time.